All right. Today, quick and dirty Python list 3, and today it will be actually very quick. This video might seem like it's low effort, and that's because it is low effort. Okay, so we will really skip through a lot because these tasks are the same. So we have a person class, a bank account class, employee class. So I will just quickly show that person class is just defining the class, and employee class is the same, bank account is the same. I will show the only one of these because they are pretty much the same. So let's go with employee class because it has, let's say, the most complicated methods, and it shows it very quickly and very easily what is going on. So you have a class definition, and of course Python does not have brackets, so we have to use double dot. I forgot the name, sorry. Then we define an init function, and these are special functions which begin with a double underscore and end in double underscore. They are in Python documentation. You can read about all the special functions, but init is pretty much required because it's like the constructor for the class. So later, if I would like to construct an employee, I would like do equal employee, and then in these brackets I would do employee ID like this, and then employee name John. You get the idea. So this is how the init function works, and what it does really, you just set the fields because I don't know, but for some reason you do not declare fields as a class, you declare the fields in the init function. And so it's just a simple constructor, so self.id, and I guess this instantiates a field of ID. This is also very weird to me, and I didn't do the testing, but I'd assume that if you made a new field, for example, in print details, that calling this function would instantiate a new field. This wouldn't be an error, even though this field is not initialized. It's very weird in Python. But then you have the methods for the class. So you define and then the name of the method, and then you have basically the self keyword, which is the current instance. So you can define also associated methods without the self keyword, and then these are just functions which have a return value or don't have a return value. But if you include the self keyword, you can access the self keyword, so we can modify the field of the class the method has been called on. And so this is how it works. And as you can see, they can be void, like print details, or assign department. But they can also be with a return value. This time I'm returning float because it's salary, and here I have division by 50, so I need to cast int to float, and then I return the stuff. And also here, what is interesting, that the init, despite instantiating an object, does not return this object. This is how Python works. So in Rust, if you had a constructor, although the Rust is a bit different, but anyway, in Rust you would have to specify that you return the object, because a constructor is an associated method, associated function, unlike here where init, probably the existence of the self already instantiates the object. Okay, anyway, let's go to another task, because you can read all of this is on GitHub. This is just to show how classes work. And then let's talk about inheritance, and then we have two quite interesting scripts. So let's also talk about shape and its inheritance. So you have a parent class shape, and it has area and perimeter defined, and I actually put here a pass. So area returns a float and perimeter is also a float. I think it makes sense. If I am to define a circle, a square, and a triangle, I would need floats to return as perimeter or area. And here I do pass. You could do an exception, raise not implemented error. So this is like the proper way to do this, and then you would here do a message that this is not implemented or something. But I do pass because it also works. And if you call area on shape, you don't know what shape it is, and so it passes. And if circle inherits from shape, and for some reason you have a circle instance as a shape, then it will automatically dereference to this function instead of this. So, and then you have inheritance you specify with these brackets, and then brackets, parentheses, and then you specify the parent. So circle has a parent shape, and then as you can see, I did not define an init function in shape because shape cannot be instantiated, and that's quite cool in Python in terms of talking about other object-oriented languages. I wouldn't classify Python as object-oriented, although it is, but whatever. Then these are just implementation of circle. So area of circle is pi r squared, and perimeter is 2 pi r. Then the square I do by a side, then triangle by 3 sides, and then I also check if this triangle is possible to be created, and then I use a area function. I use some stuff from ChatGPT, to be honest, but I know this way of calculating the area of the triangle. I just did not remember the way to do it. I know it exists, and so ChatGPT gave it to me, and well, that's it. That's it for the shape class, and now we can go to the more interesting tasks. So let's talk about sine wave sampling. And it's about writing a program that generates a set of samples of a sine wave. And so here the parameters, but this doesn't matter. And then the realization of this is it should be realized as a class which stores the sine wave, has a method to generate sine wave samples with chosen parameters, and also has a method to plot the sine wave, and returns the samples of the downsampled wave. And so there you could also plot both sets on one figure for a comparison, and of course use NumPy and matplotlib. NumPy isn't actually that very obvious to use. You could like implement your own stuff, but NumPy is very convenient for this. So here I have a lot of comments that you could like come back to it. But the first controversial thing in this task, because 69 lines, okay. Okay, the first controversial thing about this task is the fact that you have to own a sine wave. So how do you own a sine wave? So first I initialize a sample generator with a given frequency and amplitude. And my decision for this is that a sine wave generator has a constant frequency and amplitude all the time. And so instance frequency is constant. And I could change and amplitude are constant. Okay, so this is this. And then what I do is just set the frequency. That's for storage for later. And then I do sine. So I made an anonymous function. So I assign a function to a variable So here the sign which the class owns, the object owns a sine wave. Well, I don't know how to do this, so I assign a function which has amplitude and frequency. Actually, what's cool, what's weird or cool, I don't know, the amplitude is not stored as a field in this class, but I don't think it was necessary. You could, but you don't need to. Then there is also the sine val, which is for the downsampled wave. This is for caching the result. I actually did not implement a way to check, and yeah, I also did not implement a way to check if I need to recompute the samples, but then this is how I do the samples. So if you don't know about samples, then I will talk how to sample waves. So first, there you have to there is a comment. So I sample the sine function owned by the object with the sampling frequency and acquisition time. So what is sampling frequency is? Well, maybe it would be better to show it in Paint. Alright, a quick intermission to show how sampling works. So we have a very ugly sine wave, and let's start with the acquisition time. So maybe let's say we interrupted the sine wave somewhere, so we start acquisition from here. Let's say maybe to here. Of course, you would rather want your sample to do an acquisition from here to here, so you sample the entire cycle. So maybe let's show on an entire cycle. So you take this interval as your acquisition time, and then when you have a sampling frequency, that means how many cycles, well, how many points you take in this acquisition time per second. Although I don't really know what they meant in this task with the sampling frequency, so I implemented it as if I had, let's say, a sampling frequency of 10, then I would have 10 samples taken in this interval plus the start and end point. So let's maybe make some sampling frequency. So this would be exactly these lines. And then what sampling is, you take along these, you take points. So here in blue, I take points. Okay, and so after taking the points, then you have the sampled wave, which would be just connecting those points, and maybe in a straight line, really. So if I make from here to here, then to here, like this. And as you can see, if I now put the sine wave, so the sine wave is like this, and then look how close this green one is to a cycle. It has, let's maybe add a background, it would be easier to see. So look how close it is to a sine wave. Of course, my sine wave is drawn by hand, so, and also this one is drawn by hand. But as you can see, with these straight lines, I'm actually approximating the wave quite well. And so if you have a good sampling frequency chosen to good acquisition time, then you can pretty much get the sine wave. It will be slightly jagged on the corners. It will have corners, of course, but it is quite close. You can tell that it's a sine wave, yes? And then if you even increase the frequency, so let's maybe say that we have a bit more points. So let's get rid of this. Now let's say I have way more points. So let's add blue. And let's say I have points here, 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 here. And you know, I doubled the amount of points. Then you can probably guess that the wave will be even better. Let's make this one in pink. And so if we now take a look at the green wave, as you can see, well, the pink wave here I cannot draw well, so you can think of this being more flat. But as you can see now, it is more round where it should be more round, and this is what basically sampling is. Although this would be something for humans on an oscilloscope. Sampling of something like this would be more, let's maybe do a different color, maybe like this. Sampling could look like, what is, let's maybe choose a better color. So sampling would be something like this on an oscilloscope. So this wouldn't be that good. This is what would the sampled wave look like, because you have one signal for some period of time, then another for some other period of time. But if you make this make more points, then you can also get the better signal, and so this would be the output from a microcontroller, for example, of a sampled sine wave that you would do with this program. But I don't know which one they wanted, so I implemented the first one, which is this one in green, and this one in pink. So these are the same, just more points on the pink one. And so this is what basically sampling is, and if you didn't know, now you know in very basic terms. And this will be shit to edit. And so this is what I do. So first I take x values. So I need x values. So I take x values for the, let's say, the original sine wave, and I made them very fine. So I make 10,000 points for the sampling time. Yeah, and so this is my x values, and then I store the sine values, which is also sampling, but it's not sampling with the parameters given. I store the sine values as a tuple. So you have, in the first position, you have the x coordinate, and in the second position, you have the y coordinate. So like this. And then I take the time interval of sampling. This is actually the same length, really, to the sine values, but I think that's the you could optimize it by just doing one cycle of the sine wave and then doing some programming manipulation, but this is Python. We don't really care about optimization. But here I take the acquisition time, so from 0 to acquisition time, and then frequency amount of samples. So they are spaced 1 over frequency. So these are evenly spaced samples. And then the sampled values are basically the same thing. So we take x values, but this time downsampled, let's say. And then I take time interval. So I take sine of every point that I did the sample in, and then I return this tuple. And then here I have a sample to plot function which just plots the value. So there were plots in the previous videos. I won't really talk a lot about it. It just here takes the sample values by sampling and then plots it, and also plots the sine values and here I use the cached sine values. Well, I didn't do it intentionally, but an optimization, because here caching, you overwrite, when you call the sample function, you overwrite this cached sine values, and I call the sample function inside of this function, and that's how, that's why I can also get this. I don't need to return both values. And so I have simple plotting, so this will be visible later. And then frequency, type your index number and modulo 100. That's basically fulfilling this requirement. Frequency last 2 digits of a 6-digit number, and it's in hertz. and if it's 0, then use 1. So here I do if it's 0, then use 1. And then I take the amplitude, and then the frequency is determined from here. And so it creates the generator. So this instantiates an object of constant frequency and amplitude. And then you select a sample rate and acquisition time, and then I call the sample to plot. So you have a plot available to you instantly, and then we can actually check it. Okay, I wanted to get some good values, and so this is the plot we get. So amplitude 1, so from -1 to 1. And then the samples here are the dots. So as you can see, this is not a very good sampling. I mean, you could say that the sampling frequency is the frequency over one cycle. Then this would be good sampling because it's to 20 hertz. So you can see the points here are very sparse, so you could increase the sampling. So let's maybe do, that's 200 hertz over 1 second. And as you can see, the points are now much closer. So if you do straight lines between them, you will get quite a good sine wave actually. Although it would be better to choose a sampling rate which is coinciding or which is a divisor or which is a multiple of the original frequency, because then you would get all the time at the peak. So you would catch all the amplitudes. But this is also good. Because if you connect this with a line, then you get a nice sine wave downsampled from less points, because as you can see, the orange line has a lot of points. I cannot actually, or I can actually go closer. As you can see, the line is quite good because I have 10,000 points for the line. But well, that's it. So that's it for the sine wave sampling. And now let's talk about the last one, which is, let's say, a bit easier on the head. And so the last one is the interactive Scrabble calculator. So I just made it into a Scrabble game here. But you have to write the same thing which was in list 1 with the Scrabble. So we have Scrabble calculator, and I just have a function. Or not even a function. You just input a word, but you could put this input to a function and then return the score for the word. So here this is exactly that. And yeah, it has a calculator and whatnot. So we have a class player, and as I said, you cannot instantiate fields. You don't declare the fields of the class, but if you have constant fields, then you do. And I have a constant field of scores because, well, scores in Scrabble do not change. And so this is a simple dictionary of letter and then the score for the letter. And then I have an init because it's a single Scrabble player. So you just have a score of the player 0 and then the name. Then you have score word. So this is when the player gets a good word, and so it has a so you input the word, and then the multiplier for the word. By default it's 1, and then you calculate the value of the word, and then you add it to the player's score. Then we have parse input. So this is basically the function which was in list 1, the input function, just as I have shown, and it returns a tuple of string and int. So int is the multiplier, and the word is the string. And then we have a return or an exception if the input is something not expected. And then we have a simple program. So first, player count, we ask how many players will be in this game, and then we add the players into a list. So we append a player to a list, and then we have a running loop with current player being 0. And so we print the turn, which player is now. Then I made a quick parser for commands so that you can exit or display the scores. And then you type the word and optionally a multiplier after a comma. And so there is the input. So I check for the command. So if it's exit, then running false, and then it falls through to the end. Then if the input is scores, then I display scores. So for every player, I display their score. And then if skip, then you can skip the turn. I don't actually know if you can skip a turn in Scrabble. I think you can. So I added this. This seems like an interesting thing. And always I get the next player, and I wrap around if I reach the end by modulo of the length of players. And then if it's not any of the commands, I just unpack the parse input into word and multiplier. So parse input is what was in the list one, and then I just take the current player and add this word to their score, and then current player is changed again. And then if you do exit, so you fall out of the running loop, and so game over, final scores are displayed again. So we can actually check how this works. So let me clear, and let's do Python player class. Player count for this game, let's do 3. John, me, dog. So John's turn, and you type a word, so let's do chair. My turn, so I will do table with a triple, and let's say I want to check the scores. So John is 10, me is 21, and dog is 0, and it's still dog's turn, but let's say dogs want to skip, so skip, and then John's turn, so let's do Gentoo with, I did triple, so let's do Gentoo double. And if I check scores, then the scores were added, and it's my turn, but let's say I rage quit because he used my favorite Linux, so I do exit, and then the game over, and we have the final scores here. And so that is it for this list 3. I will now commit the changes because I made a few. So git. So I will commit the change, but basically that's all for this video, and I hope you could learn something from this and you didn't think it was very low effort. I've spent quite a lot of time talking about this stuff, so I think I should be rewarded, but that's maybe my thinking. Python is very low effort, so I don't want any rewards. I just want people to learn it for some reason if they want. Because I know it, so why would I gatekeep the knowledge? So anyway, let's commit and see you next time.